Hello and welcome to this Innova Systems webinar with me, Adam Rose. In the webinar we're going to have a look at intelligent modelling within SolidWorks. I'm going to incorporate equations into that. Intelligent modelling basically means that we can go into a design and we can make adjustments to the size and the geometry of a design, and then any changes that will have to come through as a result of that can be done very quickly and effectively. So, as you can imagine, using equations within a model is a very good way of doing that. For this webinar, we're going to start off by having a look at this trailer model. And this is the basis of where we're actually going to add the equations in. We'll build equations so that then we can drive the design just based upon two dimensions. We'll have the length and the width of the model. And for any adjustments that have to be made, the model will automatically update to any changes. So it's useful to just take into account some of the terminology you might come across when working with a solid modelling system such as SolidWorks. Design intent is one of those phrases that pops up every now and then. It's a phrase, and SolidWorks define it as a way in which you can plan the model as to how it will behave when it's changed. And this is largely driven by the way it was created. So for example, if we have a design where we have a boss and then a hole that goes through that boss, if we change the position of the boss, an effective design intent would make sure that the hole would always follow along with it in the right position. So across most designs, we can say that an effective design intent is a model that can be updated with the important factors of the design staying intact or requiring minimal updates in order to go along with that change. And the important thing to take away is that this is your plan. This is, each individual own user's plan as to how the model should be built and what the most important factors are and how they would actually be incorporated into any design. One of the first places design intent actually starts within a design, and one of the first places we can actually build up intelligence is actually within the sketch of that first feature or first few features within the model. By building up sketches effectively within SolidWorks and adding sketch relations in a good way, it means that we can build up a lot of design intent from those initial stages. So to start off with, I'm going to go to SolidWorks and I'm actually going to open up a new model just using a part template. So within this first part model, what I'm going to do is to start a sketch on the top plane. I'm going to build up the basic shape of that trailer so we can have a look at the kind of things you might add into a sketch at this level in order to make sure that you've got good intelligence. I just add some simple lines into here just to build up the complexity of this sketch. So within the first part of this design, I want to make sure that if I make any change to the sketch, it will update around the center. You'll see as I drag the sketch around at the moment and change the shape of this rectangle, we're getting quite an unusual adjustment to the sketch, and it's not very uniform in the way that it updates. So one of the simplest things we can do is to add in a center line into this design and actually just go straight across the model from one corner to another. If we then attach our origin to this center point with a midpoint relationship, we can hold the thing in place effectively. We may need to just adjust the sketch to accommodate those changes, but you'll see now it's updating a lot more uniformly around this central piece. I also want to make sure that this piece on the right hand side here is also going to update effectively. One of the things we can do to ensure that will update well is to use center lines once again and attach those to the midpoints of the lines either side. So I can go from one midpoint to another, and then across to the next, and then onto the midpoint on the right hand side. And if I make sure that these midpoints are all staying horizontal, Effectively what it means is that then I get symmetry on this side on the back. I can also make sure that the size of these components will update and maintain equal spacing. You'll see at the moment it isn't. One of the things I can do here is to actually select all three of these center lines and make them equal in size. And then effectively we get a really nice smooth update. Okay, so one of the other changes I can make is just to add some more sketch geometry into here, just to add to the complexity of this item. Okay, I'm making sure that I'm not picking up any sketch relations I don't want. I almost picked up a midpoint relationship there. It will sort of limit you in terms of the other relationships you can add, so you do have to be careful sometimes about not adding certain sketch relations. So in order to get this correct and make sure that again it's updating with some kind of symmetry in here, one of the things I'm going to do is to just make sure that these lines are staying collinear to each other. And I can also make sure that the lines are going to stay symmetrically aligned around the center. So by choosing the center lines that I've already created, I can use that to then make sure that they will update together like so. One of the last things you can do is to actually select one of the lines on either side and actually make them equal in size, which should then allow you to get symmetry across the middle as well. So you can see how it's quite effective. We can add in simple sketch relations that allow us to then make changes to the design and for changes to come through quite quickly. You can see how uniformly it's updating now. So one of the last changes I'm going to do is just to add in a triangular section on this left hand side. And I've just added some simple sketch items in here along with a construction line to hold it in place. And again I'm going from the midpoint because it's very good at maintaining that symmetry. So if I make sure that this line stays horizontal, it should mean that the item will update nicely around the center with regards to this line. I do have to just make some small adjustments though, because you can see the sketch did slightly adjust when I made that change. It's just to do with the fact that we haven't got any dimensions in here at the moment. So you can just pull it around to get it back into the correct position. And just by adding a symmetrical relationship, we can get it back into the correct location. So now we've got something that updates quite nicely. I'll just drag the sketch around so it's a bit closer to what I want it to be. Okay. And we can make quite effective and quick changes in here. So now these changes have been made, one of the other things I can do within this sketch is just to add simple items like dimensions in here. And obviously dimensions aren't very intelligent on their own because we're just dimensioning one item at a time. Okay, I'll just add in some simple ones. Now with certain dimensions you may want to go through and just link them together in order to get more intelligence within the design. Okay, you can see all of these dimensions, most of them are actually at the same value. And if you do want dimensions to update together, you can create global variables to do that. In my modify dimension box, I can type in the name of the global variable that I want to create and link this dimension to. So I'll simply put in some speech marks, type in the name of the global variable I'm creating. Okay, for simplicity I'm just going to call this one global. And if you close the speech marks then, you'll see that the create global variable button appears. We can then add the global variable in other locations simply by hitting the equals on that dimension and selecting the global variables that already exist. So having linked all of those items to the same value, it then means that if any of them change, the rest will update accordingly. And we can do the same with this one as well. We can add in simple equations in here. We just put in equals once again, select our global variable, and then from this list then we can go ahead and just put in times 2, for example. And we've got a very simple equation in there. So you'll see that when we make any changes to the dimension over here, and say I adjust this one to 15, we'll see that change go throughout our sketch once we hit the tick. And you see how quickly it is to update the whole sketch at once, simply by using that combination of good sketch relations and global variables to link the items together. So now that I've built up this sketch, I'm going to go ahead and go into a more complex model. I'll open up the frame of the design and we'll skip forward a few steps. So I'm going to open up the part model that I've already created within here. Okay, this is the basis of the design. This is the frame that we're going to use to add most of the equations into. It's been created from a similar kind of sketch that we used earlier on. One of the things we might want to do within here is just to make sure that we can see all the dimensions, because when we're adding in equations, like you saw just now, actually being able to see the equations you're working on is very effective. So you can either click on them on the left hand side to bring up the dimensions, or you can right click on your annotations folder to show them permanently. Okay, once your dimensions show up, you may just have to do a possible rebuild just to get them to all come through. So just hit Ctrl and Q on your keyboard. Okay, so we can see the change coming through there, and I'll just drag out those dimensions that I'm likely to use over and over again. So the ones I'm pulling out are just those ones that I'm likely to use within this model to build up the changes that are going to come when I build the equations. One of the other things that's quite useful is turning on dimension names so that we can differentiate between the dimensions. If you go to the View menu, you can do that. Okay, and then we have all the dimension names appearing in the design. We may want to rename some of those dimensions we're going to use over and over again. Initially, when you create dimensions in any part of a model, it's going to start off by adding it in from D1 and then going up from D2, D3 and so on. So on some of these, if I double click on the dimension, you'll find the modify box come up, and in the top of the modify box we can type in the name that we want to create. So I'm going to name this dimension back. I'll rename some of the others. This one will be length. And this one over here is going to be width. So having updated those dimensions, the changes will then all be based upon these three simple items. And we'll have the other equations created on some of the other dimensions as well. So the first one I'm going to create is based upon the back of the design. You'll see if I click on my sketch 1, I can drag the size of the thing around. I've got instant 3D turned on, which means I can drag it dynamically. But you'll see as I drag the item at the moment, none of the design is really updating. It didn't have those kind of sketch relations we've just talked about. But if I do want to make some adjustments to some of the dimensions, I can do that quite effectively. I just double click on a dimension just like I did before and just put in the equal sign to create an equation. So on the back of the model, I'm going to put in a conditional statement. I can use if statements in here, very similar to like you would have in Excel or something like that. You can type in the text and then it'll highlight the item for you. And then we can start typing in our dimensions. So this is going to be based upon the length of the design. I'm going to say that if the length of the model goes over 2500, okay, I want the result to be that this dimension will be adjusted to 1150. Otherwise, if it doesn't go over 2500, I want the dimension to be 700. So using an if statement, we can get a range of values as an output from a dimension. So effectively it means that if I drag this dimension down or change it below 2500, the model will just update. And then you'll see that this dimension over here will change to 700. You may notice that we also need to make a change to this feature though. This is linear pattern 3. This needs to be taken out if the dimension goes below 700. So this is the next thing I'm going to drive within my model, and I'm going to build an equation around this one. Now rather than using the modify box, we can actually build equations straight from our equation editor. You'll see that the equations box appears on the left hand side as soon as we create our first equation. We can also go to tools and equations to bring that same thing up. Within the equations editor, we get a number of different views. We get an equation view which shows us the items separated. We get a dimension view which shows us all the dimensions in the model. And then we also get an ordered view which shows the dimensions in the order they solve. I'll switch to the equation view because I find that the easiest one to actually pick out the items from because it's broken down like it is. I'm adding an equation for a feature in here. I select the features box and then click on the feature I want to add it for in the left hand side. And then I can create my equation. So for this one, I'm going to create another conditional statement in here. We can select if statements from the functions area. So for this equation, I'm going to say that if the back of the design is less than 1000, I want the result to be that this part of the design will be suppressed. If we want to suppress something, the text is actually already created for us as a global variable, so we can select it straight from there. Otherwise, I want the result to be that this item will be unsuppressed. So by adding in that text, we can then go ahead and hit the tick, and that will create our equation for us. And we should find that then this piece disappears like it has. You can see it's now suppressed on the left hand side. The evaluate to field is very effective because it allows us to see exactly what's going on right now. And the comments field is quite useful as well because, you know, if you've added a lot of equations within the model, it's quite hard to keep track of them all. One of the things you might want to do in here is actually just manually type in a bit of a comment to help you to understand what's going on. Okay, so in this one you could say that it's suppressed or unsuppressed based upon back dimension. So a simple comment like that just helps us when we come back to have a look at it later on. Okay, so I'll start having a look at the other parts of the design now. We know that this part of the model will update nicely, and if we select the sketch on the left hand side, we can drag the dimensions around and we should see the changes being made. Okay, it's now rebuilt to take account of the second linear pattern in there. One of the things we might want to do is just adjust this central section. You'll see at the moment that things are overlapping. And we might want to adjust things like the dimension D1 here over here and D2 over here, and as well as D3 for the spacing in the center. So the first thing I'll do is start off with dimension D1. And if you select it just with one click, you've got to make sure you double click if you've got Instant 3D turned on. And that will bring up your modify box. So for this dimension, I'm going to use another conditional statement. I'm putting equals and then if. And then I'm going to relate it to this dimension that's been created over here. This is a driven dimension, and that's been created within sketch 1. So there's no requirement for it, but it's been added in as an additional item. So we're going to say that if this dimension is greater than 1650, I want the result to be that the spacing will be worked out for this item. So I want it to be this item divided by 3, or this item, and I'll select in there again, divided by 2. And that should give me the result that I'm looking for and space the items nicely. You may notice each time I add an equation, each of the items gets this little equation symbol next to them. I'm now going to add one to this dimension over here, D2. I'll bring up my tools and then equations box to do that one, just to show a variety of different ways of doing it. So in the equations box, we can select in here to click on the dimension we want to create it for, and then again we just type in what we want. So I'm going to go for if once again, and for D2 we're relating it to the width because it's going across the model. So we're saying that if this width of the design is greater than 1500, I want the result to be that the width will be divided by 3. Again, we're working out the spacing. Otherwise, I just hit another comma in there. We want it to be the width divided by 2. Okay, let's just check that's gone in. And once we finish it, we just close it with a close equation box, hit the tick, and that should create the equation for us. And you should see the values being worked out for you, so you can double check them against what you think it should be. So now that these two have been added in, I want to make sure that the spacing is correct. And this is the spacing that's worked out in the linear pattern 4. So that again is a dimension in here. You can select the item. Then rather than putting in a conditional statement in here, it is simply just to work out the spacing. So this is just a straightforward equation. I'm saying that if the width, I'm just saying the width is divided by one of the values. Now it's going to be D1 at linear pattern 4. D1 is the amount of instances in this pattern. Okay, often you'll find those items are quite small and hard to get hold of if there's a lot of dimensions around the same area. You can actually manually type in the item name. We just put it in speech marks, type in D1, and then at the feature name. So that's L pattern 4. And close the speech marks. Okay, I'll put in DI there, it just wants to be D1. And you'll see that it then accepts that item. And that wants to be +1 because we're working out the spacing rather than the amount of instances. We hit the tick in there and then it should work out the value to exactly the same as the one above. Okay. We may want to just work out one more item. I'll put in one for linear pattern 4. Linear pattern 4 again is this second instance created from here. If I select it, you'll be able to see. I'll click in here, click on the item, and this is the item we want to suppress if the width goes below a certain size. Okay, so in this one, we're going to say that for linear pattern 4, if the width of sketch 1, so that's that width dimension again, that's this one. If that item is goes below a certain value, so actually I'm going to do it, it's greater than 1500 actually. I want this item to be unsuppressed. Otherwise, I want it to be suppressed. Okay, close my brackets to finish the equation and hit the tick. So if we have a look at this now, we should find that we can drag the thing around and test out our model for those equations we've inserted. So if I click on sketch 1, It's all driven from the length and the width. So the first thing I'll do is try dragging it below 2500. Okay. We should see our dimensions update. We go below a certain size. Dimension over here will change to just one item in the middle. The width, again, a similar story. If we drag it in a certain size, we should see it update and remove the linear pattern. Okay, we have to just go down a little bit more. There we have it. So that's removed the linear pattern 4 in the design. I'll just bring the item back up to an appropriate size. And again for the width. So you can see how effective it is dragging the thing around. It's updating dynamically and really quickly for this changes. One of the things I just want to change in here is to add in one more equation which controls mirror. This mirror 7 mirrors over this beam to the other side. Obviously we don't want them to overlap each other when they go down to a certain size. So I'm going to put an equation which removes that. So again, I'll bring up the equations box, and this will be the last one I'll add into this model. So for the last feature relating to mirror 7, I want it to again be related to this gap. Now you'll see that this bit has been added in as a driven dimension. We don't always have to add things in that way. What we can do is we can manually add it in by using the measure tool. The measure tool is quite effective. We click on it and just go to a top view of the design so I can see it more effectively. We can measure from one part of the model to another. So I just put in a quick dimension. So I'm measuring from here to here. And there's my dimension. It automatically inserts it into our equation. And then what we can do is we can relate our equation to that. So for mirror 7, I'm saying that if that item goes greater than 1650, then I want it to be unsuppressed. Otherwise, it's going to be suppressed. I'll close my brackets and click OK. Okay, it did just warn us the syntax was incorrect. We'll just check that to make sure we're getting an equation that's going through okay. Okay, it's not quite accepted that one. Okay, there's our measured equation again. Okay, hopefully if we hit the tick this time it will accept it. There we go, so I hit the ticker last time, and then we should find that it all updates nicely. So having added all the equations in I need, now what I'm going to do is to open up an assembly model. So I'm going to go to File and open an assembly model that already relates to this design. I might have to just change my filter to assemblies. I can then open up this trailer. So this will update dynamically, automatically to any changes we've made. Okay, there we have it. Those dimensions are still showing through the design. One of the things I do want to show is the fact that if we go below a certain size on here, okay, I'll just adjust this to something like 2400. We should see the dimension at the back change to 700. However, the wheels that have been inserted in this equation also need something to drive them, to tell them to turn off when the dimension goes below 700. So we do just need to add in one more equation in here just to drive it at an assembly level. So from the Tools menu, I'll open up my equations box. I'm relating this equation to a feature, which is this derived pattern. And I'm going to say that in this design, if the derived pattern, so I'll put in an if statement, if the derived pattern obviously is driven by the dimension inside of our frame, so it's the back dimension, and you'll see that it relates it back at sketch 1 at frame. Okay, if this dimension isn't equal to 700, so we can put in two of the symbols there, then we want the item to be unsuppressed. But then alternatively, if it ever is equal to 700, we can then suppress it. We'll hit OK for that one. So we should see it disappear there, and that's what it's done. So because this dimension is equal to 700, the item is suppressed. So you can see how effective it is. We can link items straight from one dimension to another, straight from one model to another. So I was able to go into the top level assembly and pick up a dimension at the part level to link it to. And we can do that really effectively. But what if I'm working with two unrelated designs and I want to relate them together without having to put them into an assembly? Well, we can do that quite nicely with a text file. If I switch back to my original design, okay, I'll open up my equations box, and in here you'll see there's a link to external file option. We can tick that on to then browse for an external file that I've already created. So this is an equations bit of text in here. It's just simple, really 3 lines of text. It's got the name of the item, okay, followed by the dimension after equals. We've got 3 items in here, the width, the length, and the jockey wheel. The jockey wheel is that wheel in the assembly model. So I'll click out open on this one, and I can then import those as global variables into my design. And you'll see that added at the top. So I can do some really effective things in here. I can go into this equations box, add in some new ones at the bottom, and I can say that the length that I've created here is equal to the length that was added at the top. So we can select the length straight out of there, and it'll get added into my equation. Okay, just hit enter in there, and then it'll update itself to the length of whatever was entered in the box there. Okay, you may just have to rebuild. It's not quite changed that. So we can also do it for the width as well. So if you don't want to type it in, you can select it. And then we could also make that equal to the width at the top. We hit enter, and that will update the design. Okay, we click OK on this one. And we can also bring that text file in at another level. We can bring it into another unrelated file, or we can bring it into our assembly. In this example, I'm going to bring it into the assembly. So in our assembly design, I'll go to my tools and equations box once again. And I'm going to create an equation which relates to this jockey wheel. So I'll select it from the left hand side. Okay. Now I need to bring in the value first of all. So I'll read it in from that text file. I'll link external file, and then I'll browse for that same value. So here's my text file. I can read those in. Okay. And here's my equation for the jockey wheel. So I'm going to say that if the value for the jockey wheel, so another conditional statement, if this item is ever not equal to 1, then I want the jockey wheel to be suppressed. Otherwise, I want it to be unsuppressed. And I'll hit the tick in there, and that will create the equation for this one. So with the example of this assembly, if I was then to go and actually open up this text file that I've created, change some of the values, so I can change this jockey wheel to 0. I'll change this to something else in here. Okay. And I'll just adjust this value very slightly. We can hit File and Save. And then if we just do a rebuild in the design, we should see those changes come straight through. Okay, and that updates straight away, and you'll see that the jockey wheel has now become suppressed to that change. So what I'm going to do is to just save this design and close it down. But hopefully you can see with this example how effective it is building up equations in a design and using things like text files to link them together. It's a really easy way within a model to build up design intent and keep it together, so that if you do have to have a model which updates a number of times to a number of different sizes, you can put in a few equations which control it, driven by the kind of things I've shown you today, and you should be able to build up some really effective models. So thanks very much for watching. I'll just point out the future webinars we've got coming up. We've got one on the 30th of August on direct editing tools. Then we've got one on DIM Expert a week later, and then we've got one on SolidWorks Design Checker. So if you do want to get hold of any of the videos, you can go onto our website to do that. The other thing I want to point out is that we've got a 3-for-2 and all 2-day training courses as well at the moment. So that's the advanced part, the weldments and sheet metal, advanced assembly. Okay, you can have a look if you're interested in those courses. Get in touch with us and we'll see what we can do. So again, thanks very much for watching.